Lesson 7-4. Before we do that, we need to review how to simplify square roots. Now, today we're not going to use a calculator to simplify it for us. We can only use a calculator to help us figure out what numbers go into a bigger number. So, for instance, let's just start with something we all know. If I say, what's the square root of 25? Now, for the sake of geometry class, we're going to say all the answers are positive. If you're currently taking Algebra 2, your teacher's going to tell you that your answer is positive or negative, and that technically is true. But for the sake of geometry, when you have a side length, it has to be positive. We're never going to have a negative side length. So please understand that technically these answers could be positive or negative, but we're going to just say they're going to be positive. All right, so when I have the square root of 25, if I say, what is it? Most people just automatically know the answer is 5. Now, what's going to happen is the reason why it's 5 is because if I make a factor tree, I know 5 times 5 is 25. And if 5 is prime, and this 5 is prime, which means you can't simplify them anymore. So you have a square root, and you have 5 to the second. Now, what happens is the square root in the square cancels out. So that means the 5 comes out, and there's nothing inside the square root. So that's why the answer is 5. So if we can keep this idea, we need to understand that we can simplify these just by breaking down the number. So let's start. Let's take 18. And I can break 18 down any way I would like. I can divide it by 2 and do 2 times 9. I can divide it by 3. It really doesn't matter. But you just need to make sure the answer is 18. So I think dividing by 2 is pretty easy. I'm going to say 2 times 9. Now 2 is prime, so I circle it, but 9 is composite, which means I can continue to break it down. So that is 3 times 3. Now you can check this if you would like. You can take a calculator or, just multiply it in your head and go 3 times 3 is 9. 9 times 2 is 18. Okay, so we're good. So inside the square root, I have a 2, and then I have 2 of the 3's. You notice I put the powers representing how many I have. Now I like to put those in groups of 2 because 2 of them cancel out. And, sometimes I like to be silly with this and say, I'm sure you've heard like when people get married, the 2 become 1. So for instance here, these 2 3's become 1. And it gets to break out and come out of the square root sign. So when the 3's become 1, the 3 comes out. But does the 2 get to come out? And it doesn't because there's not 2 of them. Now, why does the 3 get to come out again? It's because the square root in the square cancels out. That is the real reason why it gets to come out. So my final answer is 3 root 2. Now, if you wanted to check your work, you could take a calculator that doesn't do square roots and give you a simplified version that just gives you a decimal version. Like my graphing calculator, if I type in the square root of 18, it tells me 4.24 and it continues on with decimals. If I type in 3 square root of 2 and I push enter, I get the exact same answer because they're equivalent. They mean the same thing. So that's one way to check because I will provide a calculator that doesn't do square roots for you. Now, let's do 12. I need 2 numbers that multiply to give you 12. You can give me any 2 numbers. I personally like 2 and a 6. And 2 is prime. Let's keep going. 6 is 2 and 3. So it's very similar to the previous question. But this time we have 2 2's and only 1 3. So do we have any groups of 2? And we do. So the 2 become 1 and they break out. So the 2's on the outside, but the 3, it gets stuck inside. So my final answer is 2 root 3. And again, I told you how to, you could check it, and now you know, and if you would like to do that. Moving on, we have the square root of 24. Okay, break it down any way you would like. I like 2 and 12. That's easy for me. 2 and 6. 2 and 3. Uh-oh. We have more than a group of 2. We have 3 of them. We have 3 2s. So let me show you how to deal with this. I'm still going to group these in groups of 2. I'm going to say I have one group of, I have one group of 2 here, and then these are just little separate ones. So I have 2 squared, a 2 to the first, and a 3 to the first. So what gets to come out? Well, this grouping right here, the 2 become 1 and it comes out. But these 2 don't have a group of 2, so they have to stay inside the square root. Notice there's a dot in between everything, which means you multiply them back together. So the 2 breaks out, square root sign, and then 2 times 3 is 6. So we're finished with that one. Okay, 48. You could divide by 2, you could divide by 4. There are other numbers. I'm going to choose for this one to go 4 and 12. Now those are both composites, so let's continue to break those down. 2 and 2, 2 and 6, 2 and 3. Okay, so how many groups of 2 do we have? Well, there's a grouping there, and there's a grouping there, and there's a little left over. So let's write them in here. How many 2 become 1? All right, so this 2 comes out, the next 2 comes out, but the 3 has to stay inside. So when they come out, notice there's a dot in between. So that's 2 times 2, which is 4. 4, and then 3 stays inside. And that's the simplified version of square root of 48. Now, guys, I realize some calculators will do this for you, but when it comes to I-step time, this is not on the calculator portion, so it is really important that we learn how to do this without relying solely on your calculator. So when you have 60, if it ends in a 0, I usually times it by 10, and you could divide it by 2 if you would like. It doesn't matter, again, as long as you get the same numbers. All right, so 10 breaks down to 2 and 5. 6 is 2 and 3. Everything is prime. All right, so let's group them up. I have one group of 2. So I have 2 squared, a 3, and a 5. So do I have anything that 2 of them become 1? And I do, right there. That 2 breaks out. So what do you do with your leftover 3 and 5? Do you add them or do you multiply them? And of course, that time means that you multiply them. So that is 2 square root of 15. All right, moving on. We have the square root of 75. Again, divide by whatever you want. I'm going to take 25 times 3. The 25 is 5 times 5. All right, so I have one grouping of 2 numbers. I have 3 to the first and 5 to the second. So the 2 become 1. So the 5s get to come outside. So the 5's on the out and 3's on the in. So my final answer is 5 root 3. Okay, so I'd like for you to try to pause the video, see if you could do the next 2, and then resume it and see if you can, if you have the right answers. So I'm going to continue. I have 9 and 10, 3 and 3, 2 and 5. Okay, so my answer is 2 to the first, 3 to the second, and 5. All right, what comes out? Well, here's a grouping of 2, so it gets to come out. So the 3 comes out. What do you do with the 2 and the 5? And you're right, you multiply them. So my answer is 3 square root of 10. Next one, 120. So I'm going to do 12 and 10, 2 and 6, circle the 2, 2 and 3, circle both those, and 2 and 5. Okay, now guys, I do circle the prime ones because I really don't want to forget anything when I'm finished. I have a total of 5 numbers here. How many groups of 2 do you have? Well, it looks like I only have one grouping of 2. I have 2 to the second, and then I have a leftover 2. I have 1 3, and I have 1 5. So this one grouping of 2 gets to come out. That's an arrow. And then everything that's left on the inside, you multiply back together. So 2 times 3 times 5. And you can multiply those in any order that's easy for you. So 2 times 5, that's easy. That's 10. And 10 times 3 is 30. Or I could go 2 times 3 is 6, and 6 times 5 is 30. It's all the same. So there's my final answer. Okay, so we have to use this knowledge to help us in the rest of the lesson. Okay, this is stuff that you learned in Algebra 1. If you're in Algebra 2, you also learned it there. But just want to make sure everyone was good in remembering how to do this. So let's actually start lesson 7.4 over similarity in triangles. Now we're going to start with this little equation. Now what we're going to do is the 2 numbers provided are considered the A and the B, and you're just going to substitute the A and the B for the 2 numbers and then solve for X. So on part A, I give you the 9 and the 4. So let me change colors here. All right, so this is kind of messy. I'm going to rewrite it over here so you can tell what's going on. So notice X's are in the bottom and the top diagonally. The 2 numbers that are provided, they go diagonally as well. And so if I multiply, X times X is, and you're right, X squared. And 9 times 4 is 36. Okay, so the question is, how do you solve for X? And as you can see with my work, if I square root the left side, I have to square root the right side. And remember, when you're in Algebra 2, your teacher's going to say, when you simplify it, the answer is positive and negative. But we're going to say it's only positive because side lengths can only be positive. So the square root of 36. Now this is a perfect square. This is one you may not have to do any work for. It is 6. And if you don't understand why, we can do a quick factor tree. 36 is 6 times 6. And guys, there's 2 of them. And if that's confusing because they're not composite, let's keep going. So you have 2 times 3 and 2 times 3. So you have 2 2s and 2 3s. So the first set of 2s come out. The next set of 3s come out. So 2 times 3 is 6. So that's why the answer is 6. All right, so the next one. Notice the x's are in opposite corners. The 2 numbers provided are in opposite corners, 14 and 6. And you grab a calculator and you say 14 times 6 is 84. And x times x is x squared. So I'm going to square root the right and left side, because if you do it to one side, you have to do it to the other. And then we have to make a factor tree. And so if you look up here, I'm highlighting in green. This is my factor tree. 84. Now you could divide 84 by any number it's divisible by, 2 or 4. I chose 6. And so I ended up with 2 and a 3, a 2 and a 7. So I have 2 2s. So notice Here I have 2 squared, a 3, and a 7. Now I have it all in separate little square root boxes. You can do that, or you don't have to. Like I was doing earlier, I was doing 2 squared times 3 times 7. You can do them all underneath the same square root sign. Either way works for you. You can do whichever way that you like the best. All right, so we have one set of 2's in common. Those 2's become one grouping. So that 2 comes on the outside. And I did that here. And then 3 times 7 is 21. So for C, we have the numbers 9 and 30. So 9 and 30 go in opposite corners. X and X go in opposite corners. So 9 times 30 is 270. X times X is X squared. So we need to do a factor tree. Okay, so pick any two numbers that multiply to give you 270. Again, if it ends in 0, I always multiply by 10. So I did 27 and 10. And 10 is 2 and 5, 27, 3 and 9, and 9 breaks down into 3 and 3. So we have 5 numbers this time. Okay, so I'm going to show this step. So I have a 2, I have a 3 to the second, I have a 3, and I have a 5. Now, if you don't want to put the little 1 there, you really don't have to because it's just known that there's 1 there if you don't put anything. If it's more than 1, you have to put the number. Okay, so when I look at this, I say I have one grouping of 3's. So that 3 gets to come out. And notice right here, there's a 3 on the outside. So let's multiply 2 and 3 and 5. And again, multiply them in any order. 2 times 5 is 10. 10 times 3 is 30. That stays inside the square root sign. My answer is 3 root 30. So you might be asking, why are we doing this? I don't get it. Now, if we go back to the very first one, do you see here, I'm doing in blue, where I put the little 6's in here? Now, if I put whatever my answer is back in for X, when I multiply my extreme and mean, when I multiply diagonally, I get the same answer. So just bear with me here. What's 6 times 6? 36. What's 9 times 4? 36. That one's easy to understand. Now, when you get to some of these other questions, like when it's 2 root 21, you're going to have to multiply 2 root 21 times 2 root 21, and then it's going to equal 14 times 6. And that's something you could type into your calculator, and it will tell you if they're equal. Okay, so that's how we do the square roots. Now, moving on, we have this thing called the geometric mean. I know the line's small, try to fit it in. The geometric mean to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to each other and to the original triangle. So we call this a lot of times the Goldilocks of triangles, because when you look at this, there's like the Big Daddy triangle, and then there's like the medium-sized mommy triangle, and then you have the small little baby triangle. So when I refer to it as the Goldilocks, you know what I'm talking about. It's the 3 triangles in one. Okay, so we have a geometric mean. The geometric mean for right now is this little piece right here. It is the piece that comes out of the right angle and goes straight down, and it forms another angle. And that breaks the triangle into two more similar triangles. So notice we call this the altitude and the geometric mean. Now, some people really like to break this up and draw all 3 triangles. And I see the benefit in this. This, to me, is harder than doing it other ways. So sometimes on your paper, if there are 3 triangles here, that is to help you write out your similarity statements. Now, I'm going to show you my way of doing this. This is just my personal way that I like to do. So on the first one, I have RSQ. RSQ goes this order. Now, when we look at a triangle, I need to back up for a second. When I look at a triangle, we have, now this is a right triangle, we have the hypotenuse. Okay, that's always opposite this right angle. And then the other two sides are legs. Now, one leg is shorter than the other. So one is the short leg and one is the longer leg. Okay, so we have short leg, long leg, and the hypotenuse. So if you look how I put the arrows here on this one, what order am I going in? I'm going down the long leg, up the short leg, and then finally going back down the hypotenuse. So my order is long, short, hypotenuse. Now guys, this helps me, and I'll show you why. Now I have to write down that order, and I wrote it down right there. Now let's pick a different triangle. Let's pick the mama triangle right here. On that mama triangle, can you tell me where the long leg would be? Maybe it might be easier to pick the hypotenuse. Let's find the right angle. Here's the right angle in blue. Across is the hypotenuse. So now that you kind of see it, where is the short leg? Right here's the short leg, which means this is the long leg. Now we need to go in the order of long, short, hypotenuse. So what order would you go? Long, short, back down the hypotenuse. So R, T, S. And notice that's what I wrote here, RTS. Now, if you hate this way, you can try to draw them out into 3 separate triangles. That way works. But to me, that way is harder. But it's just, I don't know how your brain works, but for me, this is easier. Now let's look at the baby triangle. Let's label the hypotenuse. On this little tiny baby triangle, where's the right angle? It's right there. Across is your hypotenuse. Let's label that's supposed to be a short leg, and here's the long leg. Okay, so let's go in order. Long, short, hypotenuse. So go down the long, across the short, and back up the hypotenuse. So it's STQ. And that's what I have. So I verified my answers were correct. All right. So we have 2 ways to set up problems now. And one is called part, and one is called part whole. Okay, so part is when your geometric mean is here in the middle. Okay, now this is the easiest. When your geometric mean is here in the middle, it actually comes down and it breaks the hypotenuse into 2 pieces, the 2 and the 8. So what you're going to do is you're going to put the x's in opposite corners, and you're going to put the 2 and the 8. This is a picture representation of what we did earlier. So do you remember in example 1 when I gave you two numbers and I just said find the geometric mean? We're doing the exact same thing now, except for now it's in picture form. So now you could say find the geometric mean between 2 and 8, and you do it the exact same way. Okay, so remember, we're doing this stuff right here when the geometric mean is in the middle. Now, the geometric mean forms a right angle, but I want you to consider something. When you look at the next example where it says part whole, there are actually other sides of the triangle that form right angles. Doesn't this side I'm highlighting in yellow form a right angle? That could be your geometric mean. So I'm going to label it as X. Now, this is where it gets tricky. Your geometric mean is always in opposite corners, and I label them with variables. So I put X and X. So notice it says part whole. What is the part of the hypotenuse directly next to x? And that is 1. And what is the whole length of the hypotenuse? And the answer is 4. So when I cross multiply, x times x is x squared. 4 times 1 is 4. Square root both sides, and you get 2. Now, the same pattern works if you're trying to find the other leg, like the long leg. Let's call it y. The same thing works, and we're going to do an example of that right down here. We're almost finished. Okay, so let's do the one that's the easiest. When you look at example A, let's find y first. That's like the beginning of notes. When it's in the middle, this is called part. You put the y's at opposite corners. You take the 2 pieces of the hypotenuse and you make those in opposite corners and you multiply. 6 times 14 is 84. Y times y is y squared. And I'm going to square root both sides. And did I show my work somewhere? Okay, the square root of 84 is 2 root 21. And I already showed you today how to reduce that. If you need more help, please see me. Now, for x is on the side, guys. This is a part whole. So you're going to say, okay, x is what I'm finding. Those go in opposite corners. What is the part next to it that is adjacent? The part next to it that's on the hypotenuse is 6. Now here's the tricky question. What is the whole length of the hypotenuse? And the answer is 20. So there's the 20. Let's cross multiply. 6 times 20 is 120. And then x times x is x squared. I square root it and I get 2 root 30. So you're finished. On the next one, which one's the easy one? And of course that would be y. So that's part. So the y and y go in opposite corners. What's the 2 pieces of the hypotenuse? What's the 2 parts? 6 and 2. 6 times 2 is 12. Square root of 12 is 2 root 3. All right, what are the 2 parts of the hypotenuse? On the next one is part whole. So you're going to say, okay, I'm finding x. I'm going to find the part directly next to it, which is 6, and the whole length, 6 plus 2 is 8. Now I'm finding x, so x is going opposite corners. So x times x is x squared, 6 times 8 is 48. Now take the square root of 48, and that's 4 square root of 3. Okay, let's look at letter C. Okay. Again, I really like doing the part one first. Find the one right there in the middle. That would be z. So z's go in opposite corners. The 2 parts of the hypotenuse are 12 and 30. I multiply them and I get 36. And I square root both sides. The square root of 36 is 6. Okay, we have x's and y's on this one. All right, so this isn't too bad. It's the same process that we've been doing. So when you're finding y is going opposite corners. What's the part directly next to it? And that would be 3. What's the whole length? What's 12 and 3? That's 15. So 3 times 15 is 45. The square root of 45. I see a little typo. That should be y squared. Square root both sides, and I get 3 square root of 5. Now, how's x different? Okay, x is on this side. X is going opposite corners. Now you're going to say, what is next to x? And that is 12. What's the whole length of the hypotenuse? What's 12 and 3? 15. All right, so 12 times 15 is 180. And a square root 180 to get 6 root 5. Okay, so D is probably going to be the last one that I do with you. D is a really, really tricky one. because when you look at it, usually the variable is always the one that goes in opposite corners because it's always the geometric mean because it makes a right angle. But if you look at this one, these three pieces that I'm highlighting are the geometric means. And if you notice, we don't have an X at any of the locations. So the only location there, even with a number, is the 10. So the 10 is the geometric mean. So I have 10s in opposite corners. This is a part question because it's in the middle and it breaks it into two separate parts. And my two parts of the hypotenuse are x and 4. So 4 times x is 4x. 10 times 10 is 100. I divide by 4 and I get 25. Whew, okay, so guys, this is a lot. I would like for you to try E. My answers are here on the screen, so you can freeze it and then do it and check your work. If you need more help, please come see me. Bye.